So Ohanian 6.60 says that you have two identical automobiles, one traveling on the inside lane and the other on the outside along a flat curve. So here's the outside vehicle, and this represents the inside vehicle. And they travel as fast as they each can without skidding, and you're asked which of these cars has the higher speed and which emerges from the curve first. Okay, now the reason that they behave differently is that they're going around circles of radius r. I'll just label it for the first one, but they each have their own r. And that means that they require a centripetal force, a centripetal acceleration to make it around the curve, and that has a maximum determined by the coefficient of static friction. Okay, so the centripetal force is the force of friction acting on the tires of the car. And we know that can be written as mu smg as the maximum. Remember, the actual force would be somewhat less than that if they were at lower speed. That has to be supplying the centripetal force, which is mv squared over r for each car. So we can very simply write out that, okay, the maximum speed given by this formula, v max, equals the square root. Now the m's cancel. So it's just equal to the square root of mu s gr. So we quickly find out that V max increases with radius, not linearly, but as a square root of r. So the bigger the radius, the faster you can make it around the curve, which implies the outer car has the higher speed. So that's one of the two questions asked in 660, but then it says which one gets around the curve first. And the reason that might have a different answer is that this car has less distance to travel, okay, than the one on the outer. So although it's going slower, it still might make it through faster. So how do we figure that out? Well, you should remember from high school that the arc length is given by usually the symbol S is r theta, where theta has to be in radians for this to work. So the car on the outside has to travel a larger distance, and that larger distance is proportional to r. Okay, bigger the radius, the farther it has to travel. Okay, so now if we're after the time, because we're after how long it takes to get out, remember velocity is equal to distance over time, or I can rewrite that if I'm interested in the time. Time is equal to distance divided by velocity, or speed. And that's going to be proportional. Well, the distance is proportional, we found out up here, to r, but the velocity is proportional to the square root of r. So the time is going to be proportional to the square root of r. In other words, okay, the outer car takes longer. The inner car emerges first. So that says if you're in a race, okay, then you'll be better off by taking the inner lane rather than the outer lane. Given the same coefficient of friction between your two cars, you'll actually be driving at a lower speed before your tires break loose, but you'll be traveling a shorter distance, okay, and so the net effect is you win.